Hello and welcome to the channel Science Math Engineering. Today we are going to solve the APSC Public Health Engineering Department PHED 2021 Mechanical Engineering paper for Assistant Engineer Part 2. So let's get started. A fluid is said to be ideal if it is. So when is a fluid said to be ideal? So the answer is a fluid is said to be ideal if it is incompressible and has no viscosity, that is inviscous. So these kind of fluids are all imaginary fluids, and all fluids that are in real have some viscosity. So here I have given some of the different fluids. So we'll go to the next question. What is the formula to calculate the specific speed ns of a turbine rotating at a speed of n rpm that develops the power of p kilowatt at the height of h meter? So the answer is none of the choices are correct. The formula for specific speed ns is equal to n into p to the power 1 by 2 divided by h to the power 5 by 4. In our choices, there is this choice ns equal to n p to the power 1 by 2 into h to the power 5 by 4. So that was the closest. However, it would be divide and not multiply. So we'll go to the next question. Which of the following phases is obtained as the end product after completing heat treatment cycle in austempering process? So the answer is Bainite. See, austempering is the isothermal quenching where the work is cooled from austenite temperature raised to just above ms temperature. Ms temperature is the temperature at which Martensite starts forming. Okay, so the work is cooled from austenite temperature raised to just above ms temperature to avoid the transformation to Pearlite. So we see that Pearlite is not formed, and then the work is held at this temperature and the austenite decomposes to lower bainite. So this process is known as austempering. So we'll go to the next question. A boat sails across a river with a velocity of 10 km per hour. If the resultant boat velocity is 14 km per hour, what is the velocity of the river water? So the answer is C. So here we can see that the boat, we can consider the velocity of the boat is Vb. Then the river, as it is crossing the river, if the velocity of the river is Vr, then Vb and Vr are perpendicular to each other. Now the resultant velocity is V capital R. So we see that from our law of triangle of forces, we have that Vr would be equal to then root over small v small r, that is the velocity of the river, would be equal to square root of the resultant velocity square minus the boat velocity square. So which is equal to 9.79 km per hour. So we'll go to the next question. What is the dimensional formula for work? So for dimensional formula, we have to first break down what is work, and then we can get the dimensional formula. So the answer is work is force into displacement. So the unit of work is joule. So joule is Newton meter. Now Newton meter is what? Newton is kg meter per second square into meter. So it is kg meter square per second square. So the dimensional formula would be m stands for kg, L stands for meter, so m L square, and T stands for second, so T to the power minus 2. So m L square T to the power minus 2 is the dimensional formula. So we'll go to the next question. All heat engines utilize A. Low heat value of oil, B. High heat value of oil, C. Net calorific value of oil, or D. Calorific value of the fuel. So the answer is all heat engines utilize low heat value of oil. However, if we have boilers where secondary condensers are used, then its high heat value is expected as the water vapor is condensed, whatever other gases are condensed, and the heat is released. So here I have also given the definition of what is a low heating value and what is a high heating value. Okay, so we will go to the next question. Density of water is maximum at A 0 degree centigrade, B 0 Kelvin, C 4 degree centigrade, or D 100 degree centigrade. So the answer is density of water is maximum at 4 degrees centigrade. Okay, so we'll go to the next question. For manometer, a better liquid combination is one having A. Higher surface tension, B. Lower surface tension, C. Surface tension is no criterion, or D. High density and viscosity. So the answer is, for a manometer, a better liquid combination is one having a low surface tension, as liquid with low surface tension will have a lower capillary effect and will only rise due to pressure. So this liquid with low surface tension will only rise if there is a pressure change and not because of any capillary action. Also, high density fluids are generally desirable, but high viscosity fluids are not desirable, as if the body has if a liquid has high viscosity, then what happens is that it will not rise or fall with the change of the pressure, so means not accurately. So what we have is that we will have very less sensitive manometer, so we do not require high viscosity. So only our answer is low surface tension liquids. So we'll go to the next question. The materials having same elastic properties in all directions are called, so the answer is, these are called isotropic materials. So we'll go to the next question. Aeroplanes employ which of the following types of compressor? So the aeroplanes employ axial flow compressors. So we'll go to the next question. The endurance limit of a material with finished surface in comparison to rough surface is, so the endurance or fatigue limit of a material with finished surface in comparison to rough surface is more. So if it is finished, its endurance limit is more. So we'll go to the next question. The maximum principal stress theory is applicable for A. Ductile material, B. Brittle material, C. Elastic material, or D. All of the above. So the answer is, the maximum principal stress theory is applicable for brittle materials. So we'll go to the next question. A diathermal wall is one which, so the answer is, a diathermal wall is one which permits thermal interaction, so heat can flow. So this is a diathermal one. However, an adiabatic wall is one which prevents thermal interaction, so no heat can pass in. It is an adiabatic wall, but in a diathermal wall, heat can pass. So we'll go to the next question. The ratio of lateral strain to linear strain within elastic limit is known as, so the answer is Poisson's ratio. So Poisson's ratio is lateral strain to longitudinal or linear strain. So I have given the definition of the Young's modulus, bulk modulus, and modulus of rigidity also, so that there is no confusion with the other options. So we'll go to the next question. An object having 10 kg mass weighs 9.81 kg on a spring balance. The value of Z at this place is, so the answer is C. So let us assume that initially it is an earth, so G1 is 9.81 meter per second square. Now as the spring balance is used and it is calibrated at earth, so W1 would be 98.1 Newton. The W is equal to mass into gravitational force, so m into z, gravitational acceleration, m into z, so it is 98.1. Now the mass of the body doesn't change, so the spring indicated 9.81 kg means that the weight of the body has changed owing to change in gravity, and would have read, see, thus the spring balance, it is indicating 9.81 kg. That means what? 9.81 kg it cannot be, it is 10 kg only. However, its mass, it is showing of a 9.81 kg weight substance on earth. So this weight would be then 9.81 into 9.81, that is 96.2361 Newton. As the mass doesn't change, so from here we get Z2 would be equal to 9.62361 meter per second square. So we have none of the options is correct. However, had it been said that our weight was, given as 10 Newton and now it is 9.81 Newton, then we could have got a different answer. and which would have been much more reasonable in this question. So we'll go to the next question. Which of the following pumps is also called velocity pump? So the answer is a centrifugal pump is also called velocity pump. We'll go to the next question. In a compressor, free air delivered is the actual volume delivered at the stated pressure reduced to. So in a compressor, free air delivered, what is it? It is the actual volume delivered at the stated pressure reduced to intake temperature and pressure condition. So free air delivered means whatever the inlet temperature and pressure conditions were there, that temperature and pressure, whatever was the volume of the air, that volume is called the free air delivered. Okay, so we'll go to the next question. Joule second is the unit of. So the answer is Joule second is the unit of Planck's constant. So for this, I have given the unit of all this: universal gas constant, kinematic, viscous, all the options, and then I have also shown that how this we can derive that from this dimension analysis. We can check that Joule second is the Planck's constant unit. So we'll go to the next question. The index of compression N tends to reach ratio of specific heat gamma when. So the answer is when it is isentropic. So PV to the power n equal to constant is a polytropic process. Now if n equal to 0, that means P is equal to constant, so it is isobaric process. If n equal to 1, that is PV equal to constant, so it is an isothermal process. If n equal to gamma, that is an isentropic process, so S is constant. And if n is equal to plus minus infinity, any one, then what happens is that it is a constant volume process. So it is an isochoric process. So we'll go to the next question. If a fluid expands suddenly into vacuum through an orifice of large dimension, then such a process is called. So this kind of process are called free expansion. So we'll go to the next question. In jet engines, for the efficient production of large power, fuel is burned in an atmosphere of. So in jet engines, the fuel is burned in an atmosphere of compressed air. Okay. So we'll go to the next question. Which of the following factors increases hardenability of a material? Alloying element, fine grain size, very high carbon content in steel, or all of the above? So the answer is the hardenability of steel is a property that determines the depth and distribution of hardness induced by quenching. So more of the Martensite formation is there, the more is the hardenability of the material. Now whenever we use alloying elements like nickel, chromium, molybdenum, there is a delay. It delays the austenite to pearlite or bainite reaction. This permits more martensite to form at a particular cooling rate, yielding greater hardenability. So neither bainite nor pearlite is formed; these are delayed. So more of the austenite is transformed to martensite. So more hardenability is achieved. Now, if we have fine grain, what happens is that it forms more of the fine pearlite, and as fine pearlite is formed, so it decreases the formation of martensite and thus decreasing the hardenability. Then, if we increase the carbon content, it increases the hardenability up to a certain percentage of carbon. However, at very high carbon level, what happens is that the formation of the martensite is depressed to lower temperature. So the transformation of austenite to martensite is incomplete. So we do not have the full complete transformation of austenite to martensite, and we have retained austenite. So even at low temperature, we have austenite remains in its original form. So as lower martensite is formed, so hardenability is reduced. So our answer is alloying element. So we'll go to the next question. For a floating body, the buoyant force acts at the. So the buoyant force acts at the centroid of the displaced fluid. So we'll go to the next question. The primary mechanism of material removal in electrochemical machining is. So the answer is the primary machining is done for the movement of ions. So our ionic dissociation is the correct answer. So we'll go to the next question. The thermodynamic property in Kelvin scale is A. Temperature, B. Work energy, C. Heat energy, or D. All of the above. So the answer is C. If it is a thermodynamic property in Kelvin scale, then it is like there is no proper answer. But if it is a thermometric property in Kelvin scale, then heat energy should be 1. However, Kelvin scale is not like a pressure gas thermometer or like a resistance based thermometer. So like resistance based thermometer, resistance is the thermometric property. Pressure gas thermometer, pressure is the thermometric property. However, in Kelvin scale, although we cannot say it, I don't feel it, we cannot say that is heat energy, but the popular opinion in this case is that the thermometric property in Kelvin scale is heat energy. So with this we conclude the APSC P Public Health Engineering Department 2021 Mechanical Engineering paper part 2. So we'll soon come with the other parts. Thank you for watching. See you in the next one.